Write the explicit equation for the sequence that starts at 324 and then goes to 108, then 36, then 12. Well, I did a little bit of arithmetic with a calculator, to be honest, and I found out that as I move from 324 to 108, what I'm doing is dividing by 3. In other words, 108 divided by 324 is the fraction 1/3. Right? I'm dividing by 3 or multiplying by 1/3. Same thing if I take the 36 and divide it by 108. That also is the number 1/3, as is 12 divided by 36. That is 1/3. That last one I can absolutely recognize on my own. If you don't see the others, it's a good idea to just kind of look at the results when you do that division on your calculator, and see that indeed this is geometric, and every single time we move forward, we're just multiplying by 1/3. So that's nice. We have our common ratio, or the generator, for this geometric sequence. This is clearly geometric because it involves multiplication each time. Geometric sequences, they involve repeated multiplication, whereas arithmetic sequences involve repeated addition. So for this one, we're going to keep multiplying by 1/3. We do need to know the 0th term for both types of sequences. And if you look at this, this is the first, the second, the third, and the 4th term. If I want to know what my 0th term is, right, the one that comes before that, I would take the 324 and multiply by 3. And when I do that, 324 times 3 gives me a value of 972. So this is the 0th term. And at this point, we can write the rule, right? What's happening here is, I guess I'll use G for this. G of n is equal to, let's see, the 0 term is 972, and we're going to keep multiplying that times 1/3. How many 1/3? Well, it depends on where you want to stop in the sequence, but we do need to put an n here to indicate that there's going to be multiple 1/3 that we can multiply by. So if n was 1, it turns out that 972 divided by or multiplied by 1/3 would equal exactly 324. If n is 2, that would be 972 times 1/3 times 1/3, right? 2 of those 1/3, which would give me the 108. When n is 3, it's 972 times 1/3 times 1/3 times 1/3, and when you do that, you get exactly 36. And it's always good to, I do a lot of arithmetic, I do a lot of this stuff, but honestly, it's always good to go back and look at a computational device and just verify, right? 972 times 1/3 times 1/3 times 1/3. That's crazy looking, but you can see it's exactly the number 36. Instead of doing that, right, the beauty of exponential notation is I can write 972 times, and then I go 1/3 in parentheses and raise that to a power. So if I raise it to the 3rd power, you can see I get the number 36. But if I take and raise it to the 4th power, right, all of a sudden I'm sitting at 12. So again, exponentiation allows me to show repeated multiplication. Instead of multiplying by 1/3 1, 2, 3 times, I can just put a 3 in there, and that's exactly the same, right? I'm multiplying by 1/3 3 times.